All right, guys, we're back in the saddle, and we're going to continue on with Chapter 9, Section 2. This is a really long chapter. It's only 2 parts, and part is the quadratic formula. So today we're going to talk about all 3 of our objectives, which is how to derive the quadratic formula, or how they figured it out. Solving quadratic equations by using the quadratic formula and using the discriminant to determine the number and type of solutions. Okay, so objective 1, derive the quadratic formula. How did they figure this out? Well, they took ax squared plus bx plus c equals 0, and they were completing the square. All right, so by throwing that at that, what we wanted to do was, first of all, we've got to get rid of a with x squared. So we're going to divide each of the other coefficients, b and c, by a. Then we're going to get just the coefficients with x on the left, and everything else to the right. So we're going to subtract c over a from each side of the equation. From there, we're going to figure out exactly what we need to add to each side to get a perfect square, trinomial. And when we do that, so we figure you take b over a is what we have, and you divide it by 2 or multiply by 1/2. So we can follow along here. So we're going to do that right here. And then you're going to have b over 2a quantity squared. So this becomes b squared over 4a squared. So that's what you're going to have on both sides of this equation. You're going to add that to both sides. Now we're going to factor the left-hand side, and you end up with x plus b over 2a quantity squared. From there, we're going to take the square root of each side, right? So we're going to, before we get to that, they want to add, they want to combine like terms here. So to get a up to 4a squared, you have to multiply by 4a. So we're going to multiply the numerator and denominator of this fraction here by 4a. Now, all right, so now you've got that there in that second step. And now we've got x plus b over 2a quantity squared is equal to b squared minus 4ac over 4a squared. Now we're going to take the square root of each side. So x plus b over 2a is equal to b squared minus the square root of b squared minus 4ac over 4a. Right, here's what we have. Okay? Or it's going to be negative. Right? So it's either going to be positive or negative. So now we split this into 2 problems. So x plus b over 2a is equal to b square root of b squared minus 4ac over 4a squared. Well, if we take the square root of this part right here, so if we take this and we take the square root of 4a squared, that gives us 2a. Well, notice what we have here is 2a as well. So that we'll be taking, and we're going to subtract b and 2a from each side. And so that's what ends up happening. Negative b over 2a plus the square root of b squared minus 4ac over 2a. And we've got negative b minus the square root of b squared minus 4ac over 2a. And we figure out that x is equal to negative b plus the square root of b squared minus 4ac over 2a, or negative b minus b squared minus 4ac over 2a. So, quadratic formula in its final form is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. You're going to have to do as much as you can is memorize this. Or you better have it somewhere where you can look at it and know how to do it. At this point, more than likely that's what you're going to be doing. So Thing we're going to do is solve some quadratic equations by using the quadratic formula. So we're going to solve 4x squared minus 11x minus 3. So first thing we want to do is we want to figure out what a, b, and c are. Well, a is 4, and b is negative 11, and c is negative 3. And notice those are in blue, red, and green. So we're going to plug in those values into the quadratic formula, negative b plus or minus b squared minus 4ac over 2a. So we end up with negative 11 plus or minus negative 11 squared minus 4 times 4 minus 3 all over 2 times 4. And now we just simplify that. So we have 11 plus or minus 100 square root of 121 plus 48 over 8, which becomes 11 plus or minus the square root of 169 over 8. Well, it turns out that the square root of 169 is 13. Look at that, right there. So we can add 11 plus 13 over 8, and we get 24 over 8, which is 3. And we can take 11 minus 13 over 8, which is negative 2 over 8, which is equal to negative 1/4. So our solution set would be negative 1/4 and 3. Those are the two values that make this statement here true. All right, so now we've got 2x squared plus 19 equals 14x. First thing we got to always do, we got to get everything on one side of the equation. So we're going to subtract 14x from each side, and we'll end up with 2x squared minus 14x plus 19 equals 0. Now we have to figure out which one's a, b, and c. Well, a is 2, b is negative 14, and c is 19. So now we plug in to our equation. So you'll notice here, when it's a negative value, we put it in with the parentheses. I find this to be the easiest way to not make mistakes. Write out the work. Draw it all out exactly as you see right here. So negative 14 plus or minus the square root of negative 14 squared minus 4 times 2 times 19 all over 2 times 2. So we end up with 14 plus or minus 100 square root of 196 minus 152 over 4. So it's 14 plus or minus the square root of 44 over 4. And it's 14 plus or minus the square root of 4 times 11 all over 4. So 14 plus 2 over times the square root of 11 over 4. Now, because this can be factored out, we can factor a 2 out of this, and this, right? All of those can factor 2. So that's why we're doing this right here. So now we can divide that 2 out of the bottom and the numerator and the denominator. And so we end up with 7 plus the square root of 11 over 2. And we end up doing the same thing over here with 7 minus the square root of 11 over 2. Some people will write their final answers in this form. X equals 7 plus, oh geez, okay, let's do that, man. Let's try again. This is equal to 7 plus or minus the square root of 11 over 2. That's what takes care of all that mess. Okay, so there's your solution set right there. 7 plus or minus right here. Okay. There it is. All right. Now we've got it factored out. X plus 5 times x plus 1 equals 10x. So we're going to have to go ahead and FOIL that. X squared plus 6x plus 5 equals 10x. We're going to subtract 10x from each side. And we're going to end up with x squared minus 4x plus 5 equals 0. So now we end up with 1, negative 4, and 5 with equal to a, b, and c. So we're going to plug in. Okay, it's just this plugging it in, and now you just simplify it. So 4 plus or minus the square root of 16 minus 20 all over 4. 4 plus or minus the square root of negative 4 over 2. Now, when we have a negative value under the radicand, under the radical sign in the radicand. What we have to do, we got to turn it into I. So square root of -1 is I. Square root of 4 is 2. 4 plus or minus 2I all over 2. And then this would be 2 times the quantity 2 plus or minus I over 2. So our final answer is 2 plus or minus I. And that's your solution set. Let's talk about this. Back here. So what is the discriminant? Well, in the quadratic formula, okay, so it's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, right? That's our quadratic formula. Well, the discriminant is this piece right here. That piece there is known as the discriminant. You know what? I'm going to erase that. Discriminant. Okay, so this is right here. And since we have to evaluate this anyway when we're doing this work, sometimes it helps to do a little bit of, to get some clues from it. And that's what we'll be doing with the discriminant. So, if the discriminant is positive, okay, if it's positive, and the square of an integer, so it's a perfect square, then there's two rational solutions to the problem. Okay, so now if the number is positive but not the square of an integer, okay, so such as like positive 35, we would have two irrational solutions, right? Now, if it's equal to 0, there's only one rational solution. If the value is negative, there's two non-real complex solutions. Okay, so this is the one you want to keep an eye out for. Right here, negative. Okay, so here we want to find the discriminant and use it to predict the number of type of solutions for each equation. Tell whether the equation can be solved by factoring or whether a quadratic formula should be used. So let's take a look here. A is 10, B is -1, C is -2. So we plug in b squared minus 4ac. So -1 quantity squared minus 4 times 10 times -2, which is 1 plus 81, which is 81, which is a perfect square. So we can actually solve this equation by factoring, and we don't have to use the quadratic formula. Now, in part B here, letter B, excuse me, we have 3x squared minus x equals 7, so we want to subtract 7 from each side. Then we plug into the discriminant. We have 1 plus 84, which is 85. So we want to use the quadratic formula. So you can basically take this part now and put that just the square root of 85, put 85 under the square root sign and continue on with your evaluation of the problem. Letter C, 6x squared plus 25 equals 40x. So we subtract 40x from each side of the equation. A is 16, B is -40, C is 25. We'll plug into the discriminant. So -40 squared is 1600 minus 1600, so we get 0. Well, this means there's going to only be one rational solution. So you can solve by factoring. Just go ahead and factor it out. Okay. Find k so that the equation will have exactly one rational solution. X squared minus kx plus 64. So basically what you're going to do is you're going to plug in to have one rational solution. So we don't know. We know that b squared minus 4ac is equal to, well, where we have negative k squared minus 4 times 1 times 64. So k squared minus 256. So we're going to set that equal to 0. Okay, we're solving a quadratic here. And this is a difference of two squares because 256 is a perfect square. So k, or we can just use the square root theory. Anyway, we can just divide, square, take the square root of 256, so k is 16, or k is equal to negative 16. So those are the two values that will have a rational solution. Okay, if we have negative 16 or positive 16. So what they're saying here is that this final equation would have to be x squared. Now if it's positive 16, this sign is negative. Minus 16x plus 64 equals 0. Or x squared plus 16x plus 64 equals 0. Okay?
That's all, folks.
Look for some more example problems on the Google Classroom page. Have a good day.